Hello all, welcome to the lecture series of cloud computing. Today we'll see virtualization in cloud computing. Before starting with the lecture, let me introduce myself. I am Professor Poonam Mahale, working in Kekewa College of Engineering Education and Research. So let's start today's lecture with the definition of virtualization. We use virtualization every day Today, computers have tons of storage capacity and processing power in inexpensive RAM. But is that computing power used efficiently? Unfortunately, the answer for this question is no. When the hardware and processing power is underutilized and electricity is wasted, then virtualization helps to solve this problem by creating virtualization layer between hardware component and user. So virtualization plays a very important role when the resources are underutilized, and with the help of virtualization we can utilize underutilized resources. So in cloud computing, how we define virtualization? Virtualization refers to the act of creating a virtual or rather than actual version of something, which includes virtual computer hardware platforms, storage devices, and computer network resources. Virtualization is creation of virtual servers, infrastructures, devices, computing resources. So we create virtual version of IT infrastructure. It can include a computer resources, servers, application, or anything. So virtualization, it is a technique which allows to share a single physical instance of a resource or an applications among multiple users, multiple organizations, or multiple consumers. So the most important goal of virtualization is to centralize the important as well as administrative tasks with the parallel management of scalability and workload. So virtualization it does by assigning a logical name to a physical storage and providing a pointer to physical resource when it is demanded. So there are various reasons which shows the need of virtualization. One reason can be an resource optimization. Nowadays, the computer resources are very powerful. Computer resources have excess capacity, but these resources are underutilized. So, these underutilized resources can made a utilized one or can be converted into utilized form with the help of virtualization. So, virtualization plays a very important role. Virtualization maximize the uptime. So agility is the capacity to respond frequently changing requirements in quick and flexible manner. Virtualization provides a new opening to a data center administrator which allows user to have assured uptime of servers and application. Very fast disaster recovery is possible with the help of virtualization. With the help of virtualization, we can easily migrate workload as need change. So migration means shifting the server environment to another location. In virtualization, it is easy to move a virtual machine from one physical machine to another physical machine without any disturbance. Virtualization also saves resources and money, and that's why we need an virtualization. So profit is the most important aspects of any organization. Saving expenses can also be termed as a profit. So virtualization minimizes or may completely omit the need of maintaining server, desktop and data storage machines. So and that's why we need an virtualization. So there are many reasons why we required an virtualization. This diagram basically specify how the traditional system works. A traditional computer runs with a host operating system, especially that traditional system is tailored for its hardware architecture. In the diagram, you can able to see a traditional computer system is having an host operating system, hardware and application. After virtualization, different user applications are managed by own operating system, which is called as a guest operating system. So virtualization leads an introduction of guest operating system. An application can make a use of guest operating system. So user applications are managed by guest operating system and can run on the same hardware independent of host operating system. So here host operating system is there, but the applications are making a use of guest operating system. They are not dependent on host operating system. They can run on the same hardware independent of host operating system. And this is often done by additional software which is called as a virtualization layer. So here virtualization layer is inserted and virtualization is created with the help of hypervisor. And yes, that's why we need a virtualization. And when we use a virtualization, yes, virtualization is having certain disadvantages also. Now we'll see the disadvantages of virtualization. Yes, we need to create an virtualization layer, and for that we require an hypervisor. So it's an different approach of cloud computing, and that's why the first disadvantage is it can be expensive. One of the important thing in case of virtualization is the cost, but obvious. So cost is the major consideration of any organization. Virtualization can be quite a pricey investment. For installing the virtual server, one time heavy investment is required, which is more than the cost of traditional server. Again, the second disadvantage of virtualization is it creates a security risk. In virtualization system, sometimes the maintaining security of data gets difficult, and if the data is not secure, it will lead to an security risk. Third disadvantage of virtualization is it creates an availability issue. It is a little bit uncertain that every time there will be availability of resources. Hence, at crucial point, if the resources not get available, then it affect work efficiency as well as credentials of the company. So yes, if we are using a virtualization, we may face an availability issue. Then fourth disadvantage is it needs a training to network administrations or administrators. Another drawback of virtualization is the necessity to spend time and money for training purpose of network administrator, which is an additional expense. So yes, it is an disadvantages. And another disadvantage of virtualization, which is not mentioned here, virtualization might not be compatible with other servers and application. This is another drawback. It may be possible that not all servers and all applications are virtualization friendly, right? This can be a big headache when an investment has already been made on number of servers, or if the softwares used in the business process is not an upgraded version which allows for virtualization, then it will leads, and it is a big disadvantage. Then again, one disadvantage of virtualization is scalability issue. See, there may be a sudden demand or access of large number of virtualized resources by growing business may affect the availability of resource for other small business. So scalability issue is there. Virtualization creates an scalability issue. It requires several links in a chain that must work together cohesively. There is a need of proper functioning of all the links in the chain of virtualization. Otherwise, simple tasks like saving file may also become a tedious job for a user. And that's why virtualization is not always having an advantage. So these are the tentative disadvantages of virtualization. As we have already learned, virtualization can be created by having a virtual layer, and that virtual layer can be created with the help of hypervisors. So now we'll see the term hypervisor. Hypervisor or virtual machine monitor, that is VMM, is a computer software. You can call it as a firmware or a hardware that creates and runs virtual machine. So hypervisor is used for creating virtual environment. So it can be a software, firmware or hardware that creates virtual machines, that runs virtual machine. So a computer on which a hypervisor runs one or more virtual machine is called as an host machine. So a computer which is having a hypervisor or hypervisor executing on that particular machine, that machine is called as a virtual machine or a host machine. Each virtual machine is called as a guest machine. So a virtual, this is an traditional computer. When you introduce a hypervisor, then that machine is called as an VMM, virtual machine or guest machine, which is having virtualized operating system. So the hypervisor presents the guest operating system with a virtual operating platform. Hypervisor introduces a guest operating system with a virtual operating system platform and manages the execution of guest operating system. That particular machine also handles the execution of guest operating system. So multiple instances of a variety of operating system may share the virtualized hardware resources. For example, Linux, Windows, Mac OS instances can all run on a single physical x86 machine. So this is nothing but an hypervisor. Basically, the term hypervisor is a variant of supervisor. A traditional term for the kernel of an operating system. The hypervisor is a supervisor of supervisors, and that's why the name they have introduced or the term they have introduced, that is hyper. Hyper used as a stronger variant of super, and that's why they have introduced a hypervisor term. Now hypervisor are having a types. So there are two types of hypervisor. You can see here a first type is called as a type 1 hypervisor, which is also known as a native or bare metal hypervisor. Second type of hypervisor is called as a type 2 hypervisor or hosted hypervisor. Now one by one we'll see the type 1 and type 2 hypervisor. So this is an type 1 hypervisor. Type 1 hypervisor is also called as an bare metal or embedded or native hypervisor. These are the subnames of type 1 hypervisor. Type 1 hypervisor, as you can see in the figure, in the diagram, it works directly on the hardware of the host machine. It works directly on the hardware of the host and can monitor operating system that run above the hypervisor. So these type 1 hypervisor directly run on the hardware of host machine. So hardware of host machine, and in that hardware the type 1 hypervisor can run, and this hypervisor can monitor the operating system that run above the hypervisor. this type of hypervisor is totally independent of the operating system, and the size of this type of hypervisor is small because its main function is to share and manage hardware resources between various operating systems. So what is the role of type 1 hypervisor? Share the hardware resources between various operating systems. Hardware resources are shared between various operating systems. A major advantage of using this type 1 hypervisor is that if any problem occurred in virtual machine or guest operating system, are not going to affect the other guest operating system running on the hypervisor. Yes, any problem occurred in one virtual machine or in a guest operating system, that will not going to affect the other guest operating system. That is the main advantage of type 1 hypervisor. And the example of type 1 hypervisor, I can say the example which I know, Microsoft Hyper-V, then Zen server. These are nothing but an type 1 hypervisor. Microsoft Hyper-V and Zen server, these are called as an type 1 hypervisor. Now next, that is nothing but an type 2 hypervisor. Type 2 hypervisor are also called as an hosted hypervisor. These hypervisor basically run on conventional operating system. As you can able to see, hypervisor, operating system and hardware are connected. So conventional operating system is used by this type of hypervisor. This type of hypervisor use or runs on a conventional operating system, just as other computer program do. If you install any computer program on your system, then that computer program will going to use the operating system which is installed on your desktop or on your system, right? So similarly, this type of hypervisor do. They use the operating system which is available on that system, right? A guest operating system runs as a process on the host. So a guest operating system runs as a process. Type 2 hypervisor abstracts guest operating system from the host operating system. So type 2 hypervisor abstract or don't give a detail about guest operating system and host operating system. It totally depend on type 2 hypervisor totally depend on host operating system for its operation, because it uses the host operating system, that is the operating system of particular machine. So it totally depends on host operating system, and if any problem arise in the base operating system, then it affects the entire system. If any problem occurs in this system, in this operating system, entire system will be fail or it affects the entire system. And the example for this type of operating system, this type 2 hypervisor, sorry, example of type 2 hypervisor are VMware Workstation, Microsoft Virtual PC, Oracle Virtual Box. These are the type 2 hypervisors. And hypervisor are used in virtualization. Now we'll see the implementation levels of virtualization. So the important functionality of the software layer in the process of virtualization is to virtualize the physical hardware owned by the host machine in the form of virtual resources to be utilized by the VMs. So this functionality is implemented at different operational levels. The virtualization softwares generates the abstraction of VM by inserting a virtualization layer at different levels of a computer system. So how we can insert a virtualization at different levels, at different layer. So virtualization layer, how we can insert at different levels, that we will see. So there are 5 levels of virtualization. instruction set architecture level, hardware abstraction level, which is known as an HAL, operating system level, library user level API, that is library support level, and last level is nothing but an application level. So virtualization layer can be inserted at different level. So one by one we'll see these levels. So first we'll start instruction set architecture, that is nothing but an ISA level. So in the ISA level, the given ISA is emulated by the ISA of the host machine to carry out the virtualization. So given instruction set architecture is emulated by the host machine ISA, and this emulated host machine ISA carry out the virtualization. So for example, you can consider we can execute MIPS binary code on x86 based host machine by the use of ISA emulsion, and this approach helps to execute plenty of legacy binary code which is written for various processors on any given new hardware host machine. So at instruction set architecture level virtualization is performed by emulsion process by emulting a given ISA that given ISA is emulted by host machine ISA. So ISA is an instruction set architecture that represents a hardware architecture. Now you may have a question, that is, what is emulsion? Emulsion is it is a process which enables one system to behave as another system. So here instruction set architecture of one particular machine is emulted on host machine. So that instruction set architecture behaves as an another system. The next level is nothing but an hardware abstraction level. So hardware level virtualization process is carried out in hardware abstraction level virtualization. So here this process is carried out right on top of the bare hardware. With the help of this approach, two things can be achieved. First thing, that is a virtual hardware environment is generated with the help of hardware abstraction level. So here a virtual hardware environment is generated for VM, and second is underlying hardware can be managed through virtualization. So hardware abstraction layer, that is HAL, is a set of routines in that it behaves the same way as the underlying platform, and such that programs can access the hardware directly. So hardware virtualization is carried out. So hardware can be managed through virtualization. So virtualization at HAL level generates a virtual hardware environment for VM. So the main aim of this approach is to virtualize different resources of a computer like processors, memory, input output devices. So here virtualization at a hardware level performs, that means we virtualize different hardware resources of computer like processors, memory and IO devices, and it can lead to upgradation of hardware utilization rate by multiple users simultaneously, and this is nothing but an hardware abstraction level. The next, that is the third level, is nothing but an operating system level. So this approach basically refers to an abstraction layer amongst traditional OS and the user application. So abstraction layer, a layer is introduced between traditional OS and user application. The isolated containers are created on a single physical servers by operating system level virtualization. So here operating system level virtualization we perform. Here we introduce a virtualization layer between operating system and user application. And it also creates OS instances which are used to utilize the hardware and software available in data centers. The behavior is just like they are real servers. The operating system level virtualization uh, is generally used in the creation of virtual hosting environment for the purpose of allocating hardware resource among a large number of mutually distributing users. So OS level virtualization creates isolated containers on a single physical servers, and OS instances uh, are used to utilize the hardware and software in the data center. Then next comes library support level, that is the fourth level. So as we all know, mostly application use APIs which are exported by user level libraries instead of lengthy system calls. So instead of lengthy system calls of operating system, most application use APIs which are exported by user level libraries. So as there are well documented APIs in the most of the system, they can be used as an interface for virtualization. So in a library support level, a API are used for virtualization purpose. Virtualization with library interfaces is possible by controlling the communication link between application and the rest of the system through API hooks. Virtualization using library interface is achieved by controlling communication link between application and the rest of the system, and this is done with the help of API hook. Now you may have a question, what is API hook? So API hooks is a technique by which we can modify the behavior and flow of API calls. API hooks control the communication link from the system to application, and that's why for having a communication between an application, a library support level uses an API, and that API uses an API hooks. API hooks basically used to control the communication link from the system to application. And this approach is implemented by the software tool like Wine, that is WINE, for the support of Windows application on the top of Unix host. So library support level virtualization is done with the help of API hooks, and which API hooks basically controls the communication link from the system to the application. Now next, that is nothing but an user application level. So user application level, in the user application level approach, an application is virtualized as a VM. Usually an application execute as a process on traditional operating system. When we execute any application with the help of traditional operating system, that application is generally executed uh, generally executed by considering a process. It acts as a process. Hence the user application level virtualization is important. The user application level virtualization is also called as an process level virtualization, because when we execute any application, it execute as a process. In user application level, the virtualization layer resides as an application program on top of the operating system. This layer exports an abstraction of VM which can execute applications written and compiled for a specific abstract machine definition. So when we are using a user application level. In this type of virtualization, the virtualization layer resides as an application program on top of the operating system. So on top of operating system, this layer resides. So application level virtualization comes handy when you wish to virtualize only an application. Here we does not, or here we are not virtualizing entire platform or entire system. Here we are only virtualizing the application. Here we are not virtualizing the environment. So virtualization at the application level, virtualizes an application as an VM. On traditional operating system, an application often work or execute as an process. Therefore, application level virtualization is also called as an process level virtualization. And two good examples are Microsoft .NET CLR and Java virtual machines. These are an user application level or application level virtualization. So, in this video, we have learned the basics of virtualization, the definition of virtualization, why we need a virtualization, the disadvantages of virtualization, and virtualization levels. Under virtualization levels, we have learned of 5 levels of virtualizations, that is nothing but an ISA level virtualization, instruction set architecture level virtualization, hardware abstraction level virtualization, operating system level, library support level, user application level. Hope you understood today's topic that we have learned in this video. If you have any doubt, any query, you can drop your query suggestions in the comment box. Thank you all for listening this video. Thank you.